So today we are going to start the OSI model. Okay. So yesterday we completed like the to set up the network, what things we required, and we are well versed about the connectivity and the media, right? Different types of cables, everything. Now today we are going to study about the OSI model. What we have in the OSI model, why exactly we require OSI model, that we are going to understand, right? So in IT networking, in the networking, even in the security, cyber security. So if you know the OSI model, like the traffic flow of the OSI model, how the traffic is flowing, right, between the layers. In OSI model, generally we can like we have 7 layers. Okay. So how the traffic is like exchanging between the layer to layer, that we need to understand here. So it's a kind of architecture that consists of 7 layers. So the layer one will start from the like the physical layer. Traffic will go till layer 1 to layer 7, which is nothing but application layer. So in generally in physical layer, what we have studied, right, in the yesterday's class, in physical layer we used to have a cables, right? Cables. We learned till here cables, even the RF signal also, radio frequency. Application means it's purely focus on the user, like user interface. Like the OSI model is the like interaction between it will deal with the interaction between from your user to the server, like server and client model. Let me share the PPT so that we can go ahead. So this is what the PPT for the today's class. Almost we have the 25 or 26 slides. So we'll understand briefly about how the OSI model will work and what exactly the OSI model. Now coming to the topic, OSI stands for OSI stands for Open System Interconnection. So who developed this? Okay, every protocol. See, for example, now in networking we are using every day like some few protocols, right? So every protocol has designed by some authorities. So likewise, OSI will also like developed by the ISO. Who developed this ISO? OSI stands for Open System Interconnection. It was developed by the ISO. ISO stands for International Organization for Standardization, which means it is a standardization for data communication. So OSI model, OSI layer is a reference for data communication. This is an important point. Now, it is a layer architecture. We know that in the OSI model, open system interconnection, we have 7 layers. So it consists of 7 layers, and each layer defines a set of functions. So from physical layer to till application layer, every layer will have a different functionalities. So that layer is going to perform their own functionality. So every layer define a set of functions which take place or will take a part in data communication. So for an example, so why we are using OSI model means OSI model we are going to use, right, to for the data communication. OSI model used for the data communication, and in OSI model we have 7 layers. So that 7 layers will have a different functionalities. Each and every layer will have a different functionalities. So once again, OSI stands for Open System Interconnection. It was designed or developed by ISO. Like ISO stands for International Organization for Standardization in the year of 1984, and it is a layer architecture consists of 7 layers. Each layer defines a set of function which take a place in the data communication. See, this is what are the layers. So we have 7 layers. We have 7 layers in the OSI model. In the 7 layers, see here. So layer one is the physical layer, and the layer two is the data link layer, and the network layer. Layer 1, Layer 2, and Layer 3. Layer 4 is transport layer, 5 session layer, and the Layer 6 is presentation layer. Layer 7 is the application layer. So here in the below 3 layers, right? Below 3 layers is also is called as a network support layer or the hardware layer. We'll get to know like when we are jumping into the actual content, right? We'll get to know why we are calling this 3 layers the below layer. Okay, even we can call as a top layers, or this is your bottom layers. Bottom layers, we can call anything like. top layers and bottom layers. So this below three layers, layer 1, layer 2, layer 3, is called as a network support layer or the hardware layer. Because in layer 1, which is nothing but the physical layer, what we are using here, we are using here cables, right? Which is physical. In data link layer, okay, so here what we are using, which kind of devices work here? Here the switch will work, right? So that is also a physical layer, physical device. Even in the network layer, we are going to use router also a physical device. So that's the reason layer 1, layer 2, layer 3 is called as a network support layer or the hardware layers. Clear? Now the about top layers, like the top layers are, let me change the pen. Okay, the top layers are the user support layer or software layers. The above layers are called as a software layers or the user supported layers. See here. Layer 7 is the application layer and the presentation layer, session layer. These three layers are responsible for the user machine, like the communication. If you initiate some communication, right, towards a server to client, for example, here you are sitting, this is your laptop, you have the internet ISP. In between your laptop to, right, in between your PC to internet, there are multiple devices like routers, switches, firewalls. So for the sake, just we are like directly taking the connectivity, and here we have a server like a DNS server or Google server or Facebook server. Your machine will act as a client, and this is your actual server. So when, see here, these three layers, layer 1, layer 2, layer 3 is the hardware devices, and the above top layers are the software devices or software layer. So this you can't see physically, the application, presentation, the session. This process will happen in the backend. This process will happen in backend, which will happen in the software. Like, so this process, layer 7, layer 6, layer 5 are going to help to you, like the user or client, how the data has to be represented on your screen, and how you are trying to access the application, and what time you have started accessing the application. Like if you initiate the connection from your computer or from your mobile to the Facebook server, what was the time the connection was initiated, which means session start time and session end time. So the session layer will will responsible for to maintain the session, and the presentation layer will responsible for to presenting the data. For an example, you just hit like https colon forward slash forward slash facebook.com, facebook.com. So once the request, right, on which layer you are trying to be access, like this, which layer you are trying to be browse this URL, means in the application layer. Once you hit this URL, okay, the request will go to the Facebook server, and the Facebook server will response, will provide the response. That response will present on the user monitor, like user machine. So that data will take care by the presentation layer, how the data has to be present. For an example, you just requested for the image, okay, so image will be in a JPG format, right? So that format and everything will take care by the presentation layer, how the user was requested, and how the presentation layer has to be represent that exactly, whether the user is requested for the voice related things or the video things or audio things or text, anything that will be take care by the presentation layer. And the session layer is what? Session layer is will maintain the time between your machine to the Facebook server, at what time you have logged in or at what time you have logged out. So that's the reason we used to call as a, this is a software layers which you can't see, but in practical scenario it will work in the behind. And now the finally we have the transport layer. The transport layer is the core layer of the OSI model, or else you can say that heart of the OSI model, heart of OSI model. Because whatever the data is coming from here, from the downside, are the hardware layers, are the network supported layers, which will go to here the transport layer. And again transport layer is translating between from top layer to the bottom layer, which means hardware layer to the software layer. He's the responsible, this guy is the responsible to translate the data between from software layer to the hardware layer. Clear? Now the next slide. We'll do one thing. We'll come from the down, okay, physical layer, so that you will be understand a bit easily. It would be easy. Okay, physical layer. What exactly physical layer? Let me take the snap so that we can. In physical layer, OSI model we studied in the first slide, right? OSI stands for Open System Interconnection. It is a layer architecture. It consists of 7 layers, right? It was developed in 1984. So in 7 layers, the first layer is physical layer. Physical layer. How it is physical layer? See here. Now we are trying to initiate the traffic from user machine. This is your user machine, right? User machine used to connect to the switch, and switch used to connect like router. We have any L3 device, and we have a ISP here, internet service provider. Here we have any of the web server over the internet. We have the web server. Now see how the data will be flow in between from physical layer to till application layer. So now we are dealing with the physical layer. Physical layer is the layer one. Physical layer is the layer one. Physical layer defines the electrical and mechanical functional specification for communication between the networking devices. Between the networking device to connect from this PC to this switch and this router, what we required a cables. That is what it is, cables, right? So what will happen in the exactly the physical layer is nothing but your cables, and the RF signal also will fall here. We'll discuss about that. And the functionalities in the physical layers are transmit raw binary data. Binary means data. Binary means which is in a form of bits and bytes, which means zeros and ones. So the functionalities in the physical layers are in the bits and bytes over a physical medium such as a cable. If you have some data here, you are trying to access, if you are trying to send from here, this is your source and this is our destination. When we are trying to send the data, okay, so in the data will be in the form of bits and bytes, which means zeros and ones. So that data is going to travel from this PC to this switch and this switch to laptop. Now we are dealing here, right, the physical layer. So when the data was initiated from this source machine, the data will be in a zeros and ones. The data will transfer from your PC to the switch, exactly the switch port, with the help of cable. Cable could be the cable could be like such as a copper cable or the optical fiber or radio waves. Radio waves means in this example the user is connected from the wired. If you have the wireless user, how the wireless user used to connect, this is your like laptop PC to here we have a access point. That access point we are going to connect to the switch, and this access point will broadcast the RF signal, radio frequency. Even if the user can send the data with the help of RF signal as well. And the example of in this physical layers are the Ethernet cables, which we are using here, the Ethernet cables and the switches. So to connect between the PC, between from the user or the end user or the end machine to the switch, okay, we require a switches and hubs, connectors and the electrical signal. Now see, if you are using here the copper cable to connect from your source, like from your end machine to the switch, what kind of data will be travel between this PC to this switch? It's a electrical only, right? That's what here, the electrical signal. Because in copper cable, like the Ethernet cable will have 8 pairs, right? 4 pairs, 4 pairs of cable. Pair means what? Two cables, which means we have 8 cables, 8 copper cables. Copper cable itself, what? So it whenever you are sending the data, that data will be translated from your zeros and ones in the form of electrical signal. It will go to switch. This is what your physical layer. In the OSA model, the very first layer is the physical layer, right? In OSA model, we have 7 layers. In 7 layers, the very first layer is the physical layer. This is what it is. Physical layer defines the electrical functionality specification for communication between the networking devices. and it transmits the raw binary data, which means data in the form of zeros and ones over a physical medium. This is a physical cable, right? The copper cable, such as a cable. Even we can see in between here, from switch to router, when you are configuring the trunk port, right? We used to configure in the trunk port, the uplink port, that cable we are going to connect the fiber cable. So that's the reason I mentioned here the fiber optics as well. And the radio frequency, in some scenarios we will have the users, those guys are going to connect with the help of the wireless technology as well. So in the example you can mention that like the ethernet cable or the switch or signal hub, everything. So this is what about the physical layer. So when we check here the data formation, like the data flow from, okay, the data flow in the physical layer, it will be in a bits, which means zeros and ones. Let me take this one. Now the second layer, what is the second layer? Second layer is the data link layer. In OSI layer, right? The second layer is data link layer. In data link layer, we have some other functionalities. We'll deal about that. Okay. This in the seven layers, in the second layer, data link layer has a two sub layers, which means data link layer will have a two sub layers. One is MAC, media access control, another is LLC, link logical link controller. MAC and logical link controller. Even in yesterday's class or day before yesterday, when we are studying about the networking devices, we have a router, we have a switch, right? We have a firewall, the access points, servers, printers, everything. At that time we discuss about that switch used to maintain what table? MAC address table. Switch used to maintain MAC address table, right? So on which layer switch will work? If it is the layer 2 switch, the layer 2 switch is going to work in the data link layer. So data link layer has a two sub layers. One is MAC layer, media access control, and the other is logical link control. What will happen in the MAC layer? We'll see that. In MAC media access control, it provides a reliable transmit of data across a physical link. It provides a reliable transmit. Reliable means what? Trustworthiness. So if you have a switch like this, in our infrastructure, we have a 48 ports of switch. There is a user one which is connected on port number one, and the other user is connected on port number two, PC1 and PC2. Okay. So what switch will do? Generally, switch used to maintain the MAC address table, right? MAC address table, MAC address table. So in port number one, here we have a MAC address AB colon 12 colon AC. Here we have XY colon 00 colon 13. So port number one, so the data like every switch will maintain the MAC address table, right? So on against port number one, against the port number one, the MAC address is AB colon 12 colon AC. On the port number two, we have the MAC address XY colon 00 colon 13. So this is how the switch used to maintain the MAC address table. If you want to like verify the MAC address on the switch, we need to use the command show MAC address hyphen table address. This is a command going to help you to identify on which port number which MAC address is associated. The MAC address, it will show the exactly the port number one or port number two. So here you need to use the MAC address. So once you use the MAC address, right, this command is going to help you in the production network how we need to identify the end users were exactly connected on the switch ports. So in the data link layer, what we have, right, in the we have the two sub layers. One is MAC address, MAC media access control, and second one is LLC. LLC stands for logical link control. So it provides a reliable transmit of data across a physical link. So this is our physical link, right? And the PC2 will also connect the physical link. Now PC1 has to sum some data to PC2. What will happen, right? So PC1 will become the source and the PC2 will become the destination. So it will initiate some traffic. The traffic will go to the switch. What switch will do? So when the packet is initiating from PC1, so PC will mention that, hey, my source IP is this. My source IP is x and I need to reach the destination IP x.x.x.x, and my source MAC is, so whatever the MAC address we have here, right? That is our source MAC, and I don't know the destination MAC address. For the first time, it will send like this, all FFF in all the four portions. So once the packet reaches to the switch, right? Switch used to broadcast that packet for the first time only. Switch will do the broadcasting only at the for the first time only. So once switch learn the MAC address of the destination machine on the MAC address table, from the second time onwards, switch will do the unicast, not the broadcast. So the switch will send the packet, and this guy will respond to the switch, hey, I'm belong to this destination IP address. Then the packet will be received to the destination. Now, the second packet, then again the packet has to be sent, right? The second packet will go to the switch. This time switch will not broadcast. Instead of broadcasting, switch used to do the unicasting. It will directly send because switch is maintaining the MAC address table, and right, so switch knows that where the source is connected and where the destination is connected. So that's the reason switch used to do the unicasting. Now it provides a reliable transmit of data across the physical links. Means what? So switch understand where the source is connected and where the destination is. So switch will be reliable. It means trustworthiness. Instead of sending PC2, the switch will not send the data to PC3. So that is what the reliability. Reliability means trustworthiness. And it also provides the error detection using the CRC, cyclic redundancy check, which means let me draw one more practical example so that you will understand. Okay, if you have a switch like this, 48 ports of switch in your production network, there are some API access points are connected. See, this access point is keep on flapping. Okay, keep on flapping means it's coming up and down, up and down, up and down, up and down, up and down. Then what exactly the L1 engineer will do? L1 engineer or the L2 engineer, the monitoring engineer, NOC engineer, network operational center, NOC engineer. These guys will log in into this switch. Once they log in, right, they used to verify the logs. For example, this is the port number of this switch is FA1/1. So he used to, once he log in, right, he used to perform the command show logging space pipe include, and he'll use this fast fast ethernet 1/1. So once you hit this command, right, you will get the logs related to only this port, not the other ports. We have the 48 ports of switch. So instead of seeing the 48 ports of logs, we can use this command. So if you use this command, right, you will only see the only this particular port, only this port number one logs only. If you want to see the whole logs of the switch, then the command is simple. Just hit show logging. You will see with this, with the help of this command, you will see the whole, like the complete logs of the switch. And we have some other commands also. If you use like this show logging last 10, which means only the last recent logs, last 10 logs you will be identified. Guys, note down this command so it will be helpful. Okay, when you are start troubleshooting, if someone is like, if you got the ticket like the access point or the users or some other servers which are connected to this switch which is not working properly, intermittently disconnecting or flapping, then you need to start troubleshooting. Like the first step is you need to collect the logs. So to do any troubleshooting, first we need to collect the logs. Based on that logs, we can come to the conclusion, right? What exactly the problem, whether the problem is related to the cable or the device is not getting the proper power, or what kind of VLANs we have allowed here. So that's a reason the user is unable to access. So we'll discuss on that switching part. But however, for time being, you can note down this command so it will be helpful. So it provides a like in the switch, the second point is, okay, it provides error detection using the CRC, cyclic redundancy check. So we have the another command to check the what. See, in every port will have a like the uptime of the port, like uptime of the device, and CRC errors. We can write like this: CRC errors, cyclic redundancy errors, and drops. You can see this terms in the every interface: drops and even flaps. These are practical things, guys. Even you can see these terms in your like the switch port. If you just need to run the command is show interface. This is a normal command: show interface and the type of the interface. FA1/1 number of the interface. Once you hit right, you will get the whole output of this exact port. You will get the fast Ethernet 1/1 whole output, and you will see here this terms against to this error correction. Okay, if there is some error, okay, in the connected cables or the device is generated the logs. You will see here the count 1005, like 105, the drops, how many times, how many packets got dropped. So that output you can see here. Even if you run this command, right, show interface flap, show interface fast ethernet 1/1 pipe symbol, the include, I stands for include. Here you can write error. It will just only show the error. Again pipe symbol, then flap, then again pipe symbol, then flap error and CRC. You can mention like this also. So you will get the exact output instead of running only this much of command. If you run this much of command, right, show interface FA1/1, you will get whole output like one page of output. If you run this complete command, right, you will get only error details output and the flap outputs and the CRC outputs. So this is what the first layer, which is a media access control, will do. So we know that switch used to maintain the MAC address table to send the reliable communication. Switch will learn the MAC address, the source machine and the destination machine. So when it is sending the data from one machine to other machine, switch used to take the reference of MAC address table. So if someone asks you, okay, which what table switch will use, switch maintain the MAC address table, and router used to maintain the routing table. Whenever the device has to take the decision, right, both the device, this is a switch and this is router, so this device are going to take the decision based on these guys only. Instead of taking this decision, it will not forward the packet to any port or any other devices. If you have any like errors or cyclic redundancy checks, or the link flaps or drops, so with the help of that command earlier we discussed, right, we can identify exactly do you have the logs or not. Now, the LLC stands for logical link control. It provides a communication with network layer. So what is the first layer? We have the physical layer, right? We have the physical layer. Now we are studying about the data link layer, which means layer 2 data link layer. Data link layer. Now, so what LLC will do? LLC will connect the from data link to network layer. What is the third layer? Third layer stands for network layer. So to connect from data link layer, which means from switch to the L3 device router, what we required a LLC, which means logical link control. And the functionality is provide node to node data transfer, which means from switch to router, like this. So how we used to design the architecture, right? So here we have a user, and then every user used to connect the switch, right? Every user used to connect switch, and this switch is used to connect to layer 3 device. This cable stands for layer 1, which is nothing but physical layer. Switch used to work on layer 2, which means data link layer 2, and router is what? Network layer, which is layer 3. Now see, we cleared, right, layer 1, layer 2 and layer 3. So we required a LLC between to connect from layer 2 to layer 3. That is what it is. Okay. It provides the communication between the layer 2 to layer 3 and layer 3 to layer 2. And the functionalities is connecting between node to node. Even we can say like device, or else we can say node as well. Both are same. Okay, and error detection and correction, and manage MAC address table, which means in the switch itself, switch used to maintain the MAC address table. Example on this, right, where the LLC will work. LLC used to work on the switches, bridges, Ethernet, and the Wi-Fi. This is the standard of the Wi-Fi 802.11. Whenever you see the 802.11 means this is a standard of the wireless technologies. Okay, and the MAC address. Okay, we had a class, right? What is MAC address? Media access control. It is a 48 bit of address. That 48 bit is again divided into 12 hexadecimals. Where we can find this MAC address? We have the MAC address against to NIC, network interface card. Where we will have a NIC card? NIC card will have in the user side, right? The user port. This is how the troubleshooting will has to be do. If you know the concept, then troubleshooting is easy. Let me jump how the data used to be sent here now. So the other layer, you have the data layer, right? Data link layer. Then the third layer is network layer. Let me take the snap, guys. The third layer is network layer, layer 3 in the OSI model. Network layer provides logical addressing. Okay, what is IP address? IP stands for Internet Protocol. Internet Protocol. It is a logical address, right? Logical address. And what is MAC address? MAC stands for Media Access Control. It is a hardware address. Hardware address, or we can say like the physical address also. So layer 3 is the network layer, and it provides a logical addressing and path determination. Protocol box in this layers are, we have the different protocols, and in layer 3 what will happen, we have this the path determination. Path determination means if you have a router 1 and router 2, router 3, like this, right? Now try to understand, it would be easy. See, there is a LAN here in the router 3, there is a LAN. Even in the router 2 behind also we have a LAN. In the same wise, in router 1 behind we have a LAN. So if the user who are sitting behind the LAN of router 1 has to go router 3, we have two ways. We can go via R2, we can go R3 as well. So but the nearest path is via R3, via R3. So what router will do, right? In the network layer, we are going to use the devices router. So what router used to do, it is responsible for path determination, whichever the nearest part to the destination. This guy will become the source, right? Where you have to reach, that will become the destination. So so what router will do, router has two routes. Okay, one is the primary and the secondary. Even the router will install the both the routes in the routing table, but router will always take as a primary route via R3 because it is the nearest to reach destination. Clear? So that is what the path determination example. Now we have the some few of the protocol in this layer. We can run like the routing protocol and the routed protocols. Routing protocols means IP address and IPX. IP stands for Internet Protocol. It is a logical addressing. And the routing protocol used to carry the user data between the host. Routing protocol means what? Routing protocol means it will use to carry the data, whatever the data the user is initiated from here. This is a source user, right? He has initiated some data, right? And the data has to go to the destination user. So the routing protocol will take care of that data, and it is used to carry the data between the host. Between host stand for the end user. Host means one machine to another machine. You can consider one PC to PC1 to PC2 as well. Now, another part is routing protocol. Routing protocols are RIP, EAGRP, OSPF, BGP. In routing protocols, we have three types, right? Static routing protocol, we have dynamic routing protocol, and we have default routing protocol. Again, in dynamic routing protocol, we have multiple sub protocols like RIP, EAGRP, OSPF. So the motive of this routing is what routing will do. Routing, when the user initiated the traffic, that will reach to router 1. So now whatever the routing protocol we are running here, for example, I am running EAGRP. So that protocol, that routing protocol is responsible to take the data via, should I take this way or this way? Should I take the primary way or the secondary way? So that is what the explanation is here. So routing protocol used to carry user data between the host. And the routing protocols, we have RIP, EAGRP, OSPF, and BGP. Even we have intermittent system and intermittent system. We can mention intermittent system, but this is going to be used on the ISP side, internet service provider, not in the production network mostly. Now, routing protocol perform the path determination. We just now we explained, if you have a three routers, router 1, router 2, router 3, so whichever the nearest path, right, that path is going to select the router. That is what the path determination. Now, the functionalities. What functionalities we have here? Like handling the logical address. So network layer is nothing but the layer 3, which provides the logical address. So in this layer we can see that logical addressing and the routing part as well, right? And the routing, forwarding of packets between the devices across the different network. So you can consider router 1. Here we have a LAN in one city, right? You can consider this is our India. The same kind of setup we have router 2, like we have a LAN. This is in US. So to send from router 1 to router 2, this is what the functionalities you can see here. A router used to take the forwarding of packets between the across the different networks. So here we will have a different LAN network. For example, 192.168.1.0/24. Here we should have a different network, 192.168.2.0/24. Even the WAN IP also, WAN public IPs will also be that different, right? So we can take the different we can use with the help of routing protocol, we can send the data from one logical network to other logical network, or else we can say one geographical network to other geographical network. Routers, so what devices we are going to use in the network layer? We are going to use the routers. In the routers and the router interfaces, I have a router interface. Here we are going to configure the IP addresses. That is what the IP address. ARP stands for address resolution protocol, address resolution protocol. And the ICMP is when you are start pinging, right? So ping 8.8.8.8, what is this ping, right? So ping used to work on the ICMP protocol. In ICMP we have ICMP request and ICMP reply. So when you are trying to ping some the destination machine, the Google server 8.8.8, if you are not getting the ICMP reply, means the Google services are down. So we can consider. So ping used to work on this ICMP protocol. IPv4, IPv6. In IP addresses, we have two versions of IP addresses. One is IPv4 and the another is IPv6. IPv4 IPv4 is the 32 bit of address, and IPv6 is the 128 bit of address. Again in IPv4 we have classes of IP addresses, classes of IP addresses. In classes of IP addresses we have five classes, like class A, class B, class C, class D, class E. A B C D E, right? 1 2 3 4. So D E, right? So class A B is used for LAN and WAN purpose, and class D is used for multicasting. Class E is used for research and development. See here in multicasting, we are using for LAN and WAN powers. What is LAN and WAN now? So we should have a idea of LAN and WAN. For example, there is a router in your organization, then we have a switch, right? We have few users are connected to that switch. We studied there are types of networks, right? In the types of network we have LAN, local area network, and WAN, wide area network. Even we have a MAN, metropolitan area network. See, every organization will have a ISP connectivity, internet service provider, right? So in my example, I'm going to take Airtel connection. See here. So this part, whichever the part, like, see from here, this is considered as your LAN, local area network. From from the WAN side, okay, from the WAN side, let me take the other pen. So this part is going to consider as a WAN, wide area network, wide area network. Here in the WAN side, we are going to configure the public IP address, and in the LAN side, we are going to configure the private IP address. I'm just giving the overview of the, like, what is LAN, what is WAN, and the public IP address, private IP address. So wherever you are going to take, whenever you are going to take the connection from the ISP, from the Airtel guy, that guy is going to provide the public IP pool, the WAN public IP pool, which will be /30 only, guys. Because if you studied about the IP addressing, right? IP addressing. After this concept, we have a subnetting also. Subnetting, right? We have subnet because we don't want to waste the IP addresses. We can consider here the private IPs. We can take any kind of subnet like /8, /16, or /24. But when you are going to the public IPs, right? It is a costly. We need to purchase from the ISP guy, Internet Service Provider. So if you are taking 100 of IPs means 100 IP addresses. So just to configure here, so you need your charge, your organization has to pay the bill to this ISP guy for the 100 IPs. So we require what? How many IPs? Even though this /30 pool, whichever the public IP you are getting, right, that is going to give by the ISP provider when you take the ISP link. So we just need to focus on the LAN side also. So the subnetting, we are going to learn that. So we should have a brief understanding about the IP address, then the subnetting will be easy, right? So this is what the networking device, guys. This is what the network layer. This is what the network layer. So here we are going to consider as a LAN, right? The downside we are going to consider as a LAN, and the WAN side router, the WAN interface. This is we are going to consider as a WAN. In LAN we are going to configure the private IP addresses, and the WAN side we are going to configure the public IP addresses. Right? Clear? Anyone having doubt? Just let me know. The other thing is, okay, what kind of devices we are going to use in the what kind of devices we are going to use in the network layer means, which is nothing but the router. Router we are going to use in the network layer. So we till now we clear about till here, right? Physical layer and data link layer. The third layer is network layer. So in physical layer, mostly what we are going to use, physical layer means nothing but cables, right? Cables. The data link layer, we are going to use the layer 2 switch, layer 2 switch. In the network layer, the device we are going to use router. So here we have a cables. Cables means either it could be a copper cable or the fiber cable, right? In data link layer, again we have a two sub layers. One is MAC address, media access control, and the other is LLC, logical link control. MAC address, every switch, okay, because here we are going to use the device as a layer 2 switch. So every switch will maintain the MAC address, right, to send the reliable communication, and the LLC is going to use to provide the connectivity between node to node, which means from layer 2 to layer 3. In layer 3, we are going to use the device as a router, and in router, in network layer, we have a routing protocols and the routed protocols. Okay, routing protocols will take care the data transmission between the host to host, right? So in routing protocols, we have RIP, EIGRP, OSPF, and BGP. So if you like, if we consider the diagram, okay, we done about this in the OSI model. We done about the hardware layer. These are our hardware layers or the bottom layers. So how it would be? So we have a user, right? Then we have a switch here in our organization, 48 port of switch. We have a router. Consider router means on which layer router used to work in a layer 3. Layer 3 switch used to work on layer 2 to connect between the devices. What we are using cable, which is layer 1. Any doubts still here? Can anyone confirm? Akram,
Yeah, ma'am.
clear, right?
Yeah.
So guys, if I ask, right, if you have any doubts, just let me know. Now the other layer is transport layer. It's a heart of the OSI model, right? The heart of the OSI model. Transport layer is a bit lengthy. Just bear with me. We'll finish as soon as possible. Okay. Layer 4 is the transport layer. And the transport layer provides the data delivery mechanism, which means how the data has to deliver from hardware layer to the software layer, and from the software layer to hardware layer. Who will take care? The transport layer is going to be decide the data delivery mechanism between the application in the network, applications in the network. The major functionality described at these layers are like the ensuring the data reliability. Reliability means again it is a trust whether the data is reached to the end user or not. Okay, from in example of client and server. So reliability should be there, right? Reliable data transfer and identifying services. What is services? Services is nothing but in TCP, like in the transport layer, in the OSI model of layer 4 transport layer. Identifying the services means in IT networking we have different services. For an example, HTTPS, HTTP, or you can consider HTTPS or FTP, file transfer protocol, like SNMP, simple network management protocol. Every service we are going to identify based on the port number, right? Every service we are going to identify based on the port number. HTTP port number we are going to consider this is a port number 80, and HTTPS port number is 443. So likewise we have a different protocols, like different service with the different port numbers. So in networking, we have total port numbers are 65,535. So from that, there are some registered services like HTTP is the registered service. So it already occupied the port number 80. Even though for HTTP, we can consider like if we are using in our organization HTTP service and we are going to change the port number from 80 to the customized port, we can mention like this in the server infrastructure. You will identify this 8080, you can mention like this also, but the service will work on port number 80. But this is the standard port, this is the standard port 80. Here the 8080 we are going to use, that is our custom port, customization. Okay, we are going to do the customization. Instead of 80 we using 80 and 80. So let's jump into the topic. Okay, transport layer is responsible for provides the data delivery mechanism between the application and the networks. And the major functionalities are ensuring reliable data transfer and identification of the services. So this is what the services: HTTP, HTTPS, FMT, FTP, SNMP. And error recovery, if something happened, right? Error recovery, if you are trying to send some data to your friend or from one machine to other machine, so you send it 5 packets, right? 5 data packets. So the 4 of the packets are received, 4 packets, 4 data packets reach to the destination machine. This is a source machine and this is a destination machine. Only 4 packets issued. Then this destination guy will request for, hey, buddy, you send me the 5 packets due to some congestion, okay, due to the network latency or due to some issues. I got only 4 packets. Okay, I need one more packet. So this guy is going to send one more packet. So that is what will happen here. In transport layer, majorly there will be two services, TCP and UDP. TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol. So when we are studying about the TCP, right, there you will find that reliable communication. TCP will work on the reliable communication, which means there will be a three-way handshake. What will happen? Three-way handshake. Hi, hello. Then the data will be sent. If you are not responding for hello, then data will not be sent to from source to destination. We'll study about that. So that is what the error flow and the flow control, like segmentation. Even the segmentation also a good topic. Okay, what will happen, right? Segmentation means if you are sending the data, right, data packet, the data packet is very high, so that data will not receive to the destination end. Because because if the data is 200, like 2000, okay, 2000 bytes of data. So in our like networking we have, in networking we have a term like MTU, maximum transmission unit. So how much data you can send at a time. So there will be some limit. So the standard of the Cisco standards of the MTU, right, maximum transmission unit, 1500. This is a theoretical value 1500, but in practically wherever you see, right, they will mention like 1400, because they'll reduce 100 bytes from that packet. So this packet is going to break. Segment means what? Breaking the from 2000, like this is a 2000 bytes of data. So that this 2000 bytes of data again going to be happen the segmentation. Segmentation means breaking. Once you break, right, the device itself will break. In the transport layer, the device will be break like 1400 packet, then the remaining data, remaining whatever the value, like 600, right, it will equal to 2000. So when it is breaking, right, segmentation, how the destination user will identify that. So for that, we have a sequencing also. See here, somewhere I mentioned segmentation, segmentation and reassembling, which means sequence. So it is going to be add the sequence number. So the packet one, this is a packet one, it is 1/1, it is 1/2, which means you have to combine both the packets, then only it will become the 2000 bytes of data. So that's how when it is received to the destination end, right, the reassembling will happen of the data. We'll do that. We'll understand that in the next slide. But in the transport layer, we have the major services are TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. And the functionalities of the transport layer is data delivery mechanism. It will deal about the data delivery mechanism, right? When it is when it's dealing about the data delivery mechanism, when it is sending the data from source to destination or one place to other place, one location to the other location, it will consider these points like reliable data transfer and identifying the services, whether the user has like requested or TCP or UDP based data, right? Is there any error? Okay, if it is the error, then it has to be clear that error. And the flow control, okay, if you send 100 packets, then the destination user will receive only 90 packets, then again the destination user is going to be requested for the remaining packets. That is what the flow control. And the segmentation, if your data packet is having a huge packet like jumbo packet, we used to call as a technical term jumbo packet. If the device receive the jumbo packet, then the segmentation is going to be happen, which means the packet is going to be break. Then that same packet, once it reaches to the destination, the reassembling, okay, the reordering will again will perform in this side, like the destination side. The major example, like the major services are going to use in the transport layers are TCP, UDP, Transmission Control Protocol, User Datagram Protocols, and the ports. Like see here, if you are using HTTP, so it will be the port number is 80, and if you are using HTTPS, the port number is 443. So every service will have a port numbers. Let me jump into the next slide.
क्या एक सेकंड में
Yes, yes, go ahead. Yes, buddy.
अभी जो तुम्हें बोले डेटा मैं डेटा बल्क में भेजता हूँ तुम्हारे को
Okay.
तो वो डेटा डिवाइड होकर सिगमेंट के थ्रू पास होता
Right. Segment जैसा
मतलब
pass
एक
होता.
बिट ओके ओके
Segment pieces जैसा pass होता. Let me show you that as well. I have mentioned somewhere here. See here the segmentation. Guys, I mentioned each and every point because it's a very good document. You can refer even after class also. See here. So if you're see from this is a source machine and this is a destination machine. So when you are sending the data, just consider this is the huge data. Okay, segmentation, right? Let me sequence that is, yeah, segmentation. See here, what will happen? Segmentation, the packet is going to be like give us numbers, sequence numbers, so that you are going to divide the packet and you are going to send to the destinations. Once it is reaching, right, then again reassembly will happen. That is what I mentioned here, sequencing, right? Sequencing and segmentation. See, segment segmentation refers to the process of dividing the large packet or chunks of a application data into the smaller manageable pieces called as a segmentation before transmitting across the network. Which means when you are sending the data, you just initiated the data. That data has to be reached to your transport layer. What transport layer is going to do? He is going to measure your data. Hey, it is the normal packet or the jumbo packet. If it is the jumbo packet, then the segmentation is going to be happen. Once the segmentation was happened, right, then it is going to send with the help of sequence number. It will add the sequence number, then it is going to send to the particular destination machine. Then segmentation is necessary because most networks have a limit on the maximum size of data that can be sent in a single packet. I told you, right, there is a maximum MSS. When you are configuring DMVPN, right, dynamic multi virtual private network, multi-point virtual private network. In DMVPN, we have this term MSS. MSS stands for maximum segment size. Okay, we can define how much data has to go over the tunnel, or MTU, maximum transmission unit. The standard of that MTU is by default MTU value is 1500. But however, in the production network, we will configure 1400. So we will take some grace period. Clear, Akram?
क्लियर है
Okay. So transport layer, in the transport layer, this is what the data flow, guys. Okay, data flow. We will discuss about this data flow in a last slide, so that you will be understand. Now we had a like services, right? In the transport layer, we have a services. In services, how the services are going to be identified. So before identifying the services, we should know that what is the total port count, right? The total port count is 0 to 65,535. On that ports, we have a reserve ports and the open ports. Reserve ports will fall from 1 to 49,151. The remaining ports are open ports. Here, identifying services means identifying of services is done using a port number. So we have a service like HTTP. This is one service. So what port is there to identify this service? Port number 80. And we have a HTTPS and we have a 443. If you are initiating the telnet connection, we have the port number 23. If you are if you are trying to access your router on SSS secure shell, the port number 22. See guys, this kind of services you are going to see on the application layer, but these ports you are going to see in your our devices like router switches. Let me give the example. For example, this is our like user, right? Is connected to switch. Guys, everyone, you are able to understand, right, what I'm trying to explain you. If you have any doubts, just let me know. Okay. See here we have a Facebook server in the internet. Now my user is trying to access the Facebook server, so he'll become the source. The Facebook server will become the destination. Source means what? From where the request is initiated. Destination means where the request has to be end. Okay, where the request has to be go. At least you can remember like this. So this user, what the layer 7 in OSI we have 7 layers, right? 7 layers. In 7 layers, layer 7 is application layer. Layer 6 is presentation layer. And the layer 5 is session layer. Session layer. And layer 4 again we just now we studied about transport layer. Transport layer. See here. So how we can justify what is application layer? Application layer is a software layer, right? Which means your browser. So user just log in onto the device and he open the Chrome, for example, Google Chrome. So this is what the browser. Okay. In the browser, he is going to mention now he need to access the Facebook server. So he'll mention HTTPS colon // facebook.com. Okay, facebook.com. So the request will go like to the switch, right? Then switch to router. So here you are seeing HTTPS, but in these devices, in the router, when the packet is translating, right? The router, there is a concept of network address translation. When the packet is translating on this device, there will be a source port and the destination port. Source port is always random, and the destination port is on which port this device is responding. That is called the destination port, which means in this router you can see, for example, I'll consider 192.168.1.100 is the IP address of this user. So the request will come to here, source IP 1.100 is trying to go destination facebook.com on the port number. Here you will not see the service. Here you will see the port number on 443. But user has mentioned HTTPS. But you here in the router you are going to see the 443. Even in firewall also, if you have the firewall here in place, okay, in firewall also we are going to define the services based on the port number. That is what it is. Okay, identifying the services means identification of services is done by using the port numbers. But user mentioned here HTTPS. What is the HTTPS port number? 443. That you can see in the networking devices. You will not see the HTTPS. You will see the port number. This is a practical thing, guys. Okay. And the port is a logical communication channel. In the total ports, we have 65,535. On that ports, we have the reserve ports and the open ports. Hope everyone's doubt cleared. Now, Again, in the TCP, we have multiplexing and demultiplexing. Multiplexing and demultiplexing. Let me take this slide. So, multiplexing and demultiplexing. This will happen in transport layer. So, transport layer is the heart of the layer. So, a lot of functionalities will be happen in the transport layer. Okay, lot of functionalities will happen in the transport layer. First, the first service, the first functionalities we saw that the services, right? Services, which means the port numbers, how the port numbers is going to be added. Now here in the services, again in the transport layer, we have TCP UDP. See here, so when the packet is received to this transport layer, the transport layer is going to decide whether it is a TCP service like the TCP traffic or the UDP traffic. See here, the multiplexing in computer network, multiplexing often refers to a multiple application or the process share the same network. Okay, how the same network, which means there is a user, he has the internet. Over the internet we have a multiple services, right? Multiple services, which means multiple web servers. Only this user is going to access the single user. If you open the any of the Chrome or website, right? Even the Chrome or Firefox or Mozilla, anything, he used to access in each and every tab multiple sites. In the tab 1 he is accessing the YouTube. Okay, YouTube. And tab 2 he just opened one more tab 2 is accessing like the facebook.com, and he's accessing in another tab, he's accessing the Google Chrome, something else. See here, the multiplexing means in the computer network often refers how the multiple application or the process share the same network. For example, on a server, many application, or you can consider server or the end user, many application can send data over the same network. We have the only one network, right? The guy is connected with only one ISP, and he's trying to initiate the traffic for multiple destination servers with each segment a unique port number. This is what the point we need to like give the focus. How he is going to send? In the earlier example also I told you, I missed that slide. Okay, no problem. So I told you, right, there is a router. In the router we have a NAT service, network address translation. What will happen? NAT is going to translate your private IP address to the public IP address, right? Public IP address. So when the NAT was happening here, right? So in NAT we have static NAT, dynamic NAT, and PAD. If you do the PAD, port address translation, the same user, whenever this user going to router to access some web servers over the internet, whenever he's going right in tab 1, then he'll mention, okay, he's going to the YouTube with port number 80, and he'll give one port. He's going to the Facebook, then he'll give another port. Again he's going to the some XYZ service. Okay, XYZ service is give one more port, which means port address translation. So this is what will happen every time the unique port in the multiplexing. Every time the unique port is going to be, okay, translated by the transport layer, whether it could be a TCP or UDP. Clear? The demultiplexing is, it is a reversible process. Okay, it is a reverse process of the, when the packet is coming from this internet, from this particular web servers. Okay, it will again going to the end user. That is what the reversible process will happen in demultiplexing. The receiver use the identification such as a time slot or the functions or the port numbers. When it is going to the 80, right, the request, he just requested some data to the Facebook. Now Facebook is replying. How this router is going to be like identify? When he is sending the data, he has a router has added the unique port number to reach that Facebook server. When the request is coming, right, again it will hit to that only unique port number, so that router will understand, okay, the user one has requested with the port number 80 to the Facebook server. That data is received. Now I need to send to only user one, not to user two. Because of identification, router is going to identify that which user has started the request, which user requested for the particular services. Clear? So that is what will that is will also happen in multiplexing, and demultiplexing will also happen in the transport layer with the help of TCP or UDP. TCP port number is 6 and the UDP port number is 17. See, we'll study about the basic and some points about the what is TCP and what is UDP. TCP stands for transmission control protocol. Okay, protocol which take care of data transmission at transport layers are TCP and UDP. TCP or UDP. For an example, okay, just this is a user is going to connect a switch, and again there is a L3 device which is router. We have a ISP connectivity, internet service provider. Here we have few servers, web servers, right? This is our Facebook server. This is our Gmail server, for example, Gmail server. Everything is connected over the internet. Now, this is the layer 1, layer 2 device, layer 3 device. So the traffic will receive here. Once it receive to router, right? Then the transport layer will come into the picture. In transport layer we have two services, one is TCP and UDP. So this will identify whether the user is requested TCP connection or UDP connection. Okay, TCP or UDP. So that is going to be map here in the transport layer, TCP and UDP. When the data is okay, transmission, when the data is transportation, or when the data is transmitting between the source to the destination, when the data is going from here to there, right? So when the data is coming to the transport layer is responsible to add the port numbers and the service, whether this is a TCP service or UDP service. So we'll understand what is exactly the TCP server and the TCP service and the UDP service. TCP stands for Transmission Control Protocol. Okay, and the UDP is User Datagram Protocol. The TCP port number is 6 and the UDP port number is 17. Right? That's what we saw in the previous slide as well. See here, TCP port number is 6 and the UDP port number is 17. Right? Now, TCP is a connection oriented connection. Why it is connection oriented means it's a trustworthiness. Why it is a connection oriented means in TCP transmission control protocol. Okay, whenever the user, the source, the user initiated some data, right? For example, there is a user. Okay, here we have a ISP internet connection to that user, and there is some banking server. You can consider this is your bank. Okay, bank also there. So he just type https://sbi.com, which means statebank.com. So the request will go to this guy. Okay. So in TCP, the three-way handshake will happen. Handshake. Three-way handshake will be happen. So he'll send the request. Okay. Then he'll respond with the what? This server will have a root certificate and client certificate. Okay, when he is responding, right, in the two-way handshake, there is a three-way handshake. This is the first packet you just requested like this from your browser. So all of sudden, all of immediately, this banking server is going to respond with this his client certificate. So you will have a client certificate here in this. Now the one more packet will go when you are sending the actual data, the logging, right? When the packet is going from this source to this particular destination server, the data is going to be encrypted with the help of this certificate. Whatever the data you are going to send between from your PC to this banking server, that data will be encrypted. So you are going to encrypt the data with the help of this the client certificate. The server is going to read your same encryption packet. Okay, same encryption packet with this root certificate, which means public key you can consider as a. So there is a concept of cryptography. Okay, there is a concept of cryptography. Cryptography is very important in a CIA, confidentiality, integrity, availability model. In cryptography, we have two different like keys. Uh, Symmetric, we are going to use symmetric encryption and asymmetric encryption. Asymmetric encryption. So earlier in olden days, everyone is using symmetric encryption because we don't have that much of technology improvement. So in symmetric encryption, what will happen, right? We'll have only one key for encryption and decryption. But in asymmetric encryption, we will have two keys, one key for encryption and the second key is for decryption. This is what will happen. So this is what nowadays the asymmetric encryption is going to be happen. So when you will generate the two keys and one key will give to the user and one key will have with the server. So the connection oriented means what? So the connection oriented means the connection, whatever the data is traveling between one machine to other machine, it will be before starting the connection, before sending the data, the three-way handshake will happen. Someone is unmute. Okay, Riaz, if you have doubt, just unmute or else please unmute. Okay. Uh, okay. So the connection oriented means what? So it is a trustworthiness. The connection will be trustworthiness and it will support acknowledgement. Okay. So in the first packet, the SYN request will go. In the second packet, SYN plus acknowledgement will happen. In the third packet, acknowledgement will be happen. Then only your data, actual data is going to be transfer over this link, which means this is what the three-way handshake. And it is a reliable communication. So the SYN will be sent from user to the server. Then server will respond with the SYN plus acknowledgement packet. Then the user is going to be acknowledgement. Then the actual data communication will happen in TCP. That's why it is a connection oriented and the secure protocol compared to UDP, user datagram protocol. You can see here UDP is the connectionless, which means the three-way handshake will not be happen in UDP, user datagram protocol, and no support for the acknowledgement. Here in TCP, what is happening? The acknowledgement, last packet, the third packet, first handshake, second handshake, and the third handshake, which means the acknowledgement packet will be happen. But in UDP, there is no acknowledgement support. Okay, no support for the acknowledgement. So in TCP, there is an acknowledgement and three-way handshake, and the connection oriented is there. So that's the reason it will be a reliable communication. Reliable means trustworthiness. So we have a trust. Whatever the data we are going to send, right? That data is going to reach only our banking server, not the fake server. But in UDP, user datagram protocol, unreliable communication. What we have unreliable communication. We don't know whether the exactly data is going to be reached to that particular destination or some other destination, but however we are just sending the data, that's it. Again in TCP, okay, slower data transmission. Okay, in TCP what will happen, right? The slower data transmission, the because of why exactly the slower data transmission will happen means there will be a three-way handshake will happen before initiating three-way handshake. Before sending some data, there will be happen a three-way handshake. So to complete the three-way handshake, then only the fourth packet actual data will transfer. So till then the data will not go. But in UDP, once you initiate the connection, right, the data used to go from your machine, the data used to leave from your machine. So that's the reason it is a faster communication. In TCP, three-way handshake will happen. So once the handshake was happen, it will take some time, but in UDP there is no handshake. So that's the reason the data used to go very fastly. And the port number of the TCP is 6 and the port number of the UDP services are 17. Here are some example. Okay, here are some example which we are going to use in our production network. So HTTP and HTTPS, FTP, SMTP, simple mail transfer protocol, email services, everything is a like transport hey, please guys don't disturb me if I'm in a flow, right? be be careful. Okay, if you want to talk you can like disengage from the meeting and go somewhere. You can talk and join once again, but don't disturb the other guys. SMTP stands for simple mail transfer protocol. Okay, HTTPS will also fall in the TCP because it's a secure connection. FTP means file transfer protocol. When you are sending the file from from your machine to the server, right? So the file has to be sent securely. So that's the reason we are going to use that. TCP and SMTP, when you are sending mails to your clients or your organization or your employees, so mail should also be a sensitive matter, right? So SMTP, simple mail transfer protocol, even that service will also going to use the TCP. But see here the UDP, DNS services, domain name system, okay, and the DHCP services, TFTP, trivial file transfer protocol. These services are going to use the UDP services. This is what about the TCP and UDP, which are fall under the transport layer. So where we are. Now segmentation we already explained, right? The maximum size, if the packet is coming the high size of packet like huge jumbo packet, that at that time in the transport layer the segmentation is going to be happen, and after that segmentation sequence number will be added. See here, sequence refers to the process by which TCP assign a unique sequence number to reach, right, to reach bytes of data transmitted, whatever the data you are going to transmit from this data machine to this PC2. So it will break the packet, it will TCP like transport layer is going to break the packet, segment the packet in the multiple pieces. For that multiple pieces, again he is going to add the sequence number. So this is how the sequence number is added. But because once it reached to here, right, the again the reassembly was to be happen. See here, the reassemble the original data stream, even the segments arrive out of order, even it will arrive out of order also, right, even it will arrive out of order. So again the reassembly will happen in the destination machine. This will become your source when you are sending the data, and this will become your destination. So the reassembly will happen and retransmit due to the loss, if even one of the packet got lost here, right. So again this guy is going to ask them, hey, I reach in the packet one, in pack like there is a five segments, 5 bytes, right? You have divided in the 5 segments, segment 1, 2, 3, 4, 5. I reach only 4 segments, I'm missing one of the segment, could you please send that? Then again this guy is going to send the one more segmentation. That's what your TCP three-way handshake. TCP three-way handshake is very important. If it is not there, data will go very fast, but the thing is what will happen, but the thing is, see here, so if the data was lost in between due to some reason or network conjunction, the error flow will not be happen. See here, this is a source mission and the destination mission. He just send the window size 3, he sent the 3 packets, okay, packet 1, 2, 3. Due to the conjunction of the receiver end means the destination end, segment 3 is lost. He lost this, he used to send 3 packets, he sent 3 packets, 1, 2, and the 3 packets to this destination, but he received only 2 packets, packet 3 is lost, packet 3 is lost. The window size is 2, he received only 2 packets. Then he requested to this source machine, this guy is going to send one that same packet one more time. So that is what the flow control, the controlling the flow. If your network is breakdown, and error correction, it is doing the error correction as well, that will happen, that will possible in the layer transport layer. Now, so that's it about the transport layer, guys. Okay, now we have which layer? Session layer, right? Session layer is almost responsible for only the timers. See here, only the timers. Layer 5 is the session layer. Session layer is responsible for establishing, when you has established the connection from your machine to that particular server, and maintaining till what time your connection is alive, and terminating when you disconnected from the server. For an example, this is your user. He is connected on internet, right? We have a server. We have a Facebook server. So what session table will do? First thing, establish once you initiate like https colon forward slash forward slash facebook.com. So once you initiate this connection, right, that connection will go to the Facebook server. So it will establish the connection. First, it will establish the connection. Then keep on you are like browsing some data, right? So you are maintaining the connection. Then second point also it is going to be noted down, maintaining the connection. Then once you disconnect the connection also, so the connected time and the disconnected time and the maintain time, every time will everything will maintain by the session layer in the OSI model. The functionalities is manage sessions or connections between the application, including opening, which means when you are connected, and maintain how much time you have connected, and close when you are close the session. So here are a few of the example: net bias, right? Network basic input output and RCP, which means if you take the remote connection of any of the server, so till how much time you have connected, and PPT, point to point tunneling protocol. Even to connect to different sites at two geographical location, we are going to use the VPN services, virtual private network. So there will be a timer also at what time the VPN was established, right? And what time it got disconnected or flap anything. So even when I'm working in the production networks, right, we used to have some flaps between two different sites. We have one site in India, the other side in US, right? Just for sake an example. So we are going to connect the VPN services between the two sites. Okay, if the data the LAN users are trying to access few of the servers on behind this network, right? So this is my server. So these users are trying to access some server via the VPN service. The traffic will hit to your router or firewall, and then it will go over the internet from this tunnel, and it will go to the server. All of a sudden, what will happen, right? There are some ISP issue in bit, ISP issue at US end. So this link was ISP link got all of a sudden terminated, like disconnected. So due to which tunnel will got teared down, or you can consider like closing, or you can consider this also, okay, terminated, okay, terminating, which means tunnel got disconnected. So that time is going to maintain the session layer when the tunnel. PPT means what? Point to point connection. So this is a small topic only. You can even you can study, you will understand exactly what will happen. Now the presentation layer. So before studying about the presentation layer, we need to understand what is application layer. So layer 7, the same kind of example we need to apply application layer as well. In the in the OSI model, the layer 7 OSI model, layer 7 is the application layer. Application layer is responsible for providing an interface for the user to interact the application services over the networking services. Which means if you study this point, so this is our user, he is our user as per as per this point. This is our user is having the internet, and we have a some networking services servers. You can consider SAP server, SAP server, which is an cloud. My user is having internet. So what is application layer exactly? Application layer is, and one more thing here, we have a Facebook server, YouTube server, any social media server you can consider. What is the meaning of the interface? So there is an interface. Application layer is nothing but the interface between to contact from this user to that particular server. So here our web, you can use any services, like I'm using Chrome, okay, Google Chrome. I'm just open the Chrome, and I'm typing here https colon forward slash sap.com. So whatever you type here, right, this browser will become the application, okay, application layer for user. See here, application layer is responsible for providing an interface for the user to interact the servers. So this is the application, this is the interface, Google Chrome is the interface, okay. Or you can use any other web, other machines, other search engine also, okay. That will become the interface between you and the server, where which server you are going to access. And the functionalities, see here, it is closest to the end user, which means application layer is always closest to the end user, which means the application layer, any search engine you can use, that will act as a application layer, provide the networking services directly users applications. So in this layer, what services are going to be used? We are going to use HTTP or HTTPS here. So before accessing this SAP server, I'm going to enter here the services is HTTPS. So that's what I mentioned here, HTTPS, the browser, like web browser, email client, anything. So every service will have a port number, which means whatever you just heard, open the browser and type requested to connect this particular server, right, SAP server or the Facebook server, that will act as your application server. Now in this example, again I will draw this same thing with the other pen. Let me take. Now in the second scenario, you are going to access your Facebook server, right, facebook.com. This is what your application. Now you requested images, right? Images. So that request will go to your Facebook server. So this is your request, right? Now Facebook server will reply with the images to your application, to this guy, application layer. So what application layer will do, application layer will send the data, actual data, so that data to presentation layer, because presentation layer is responsible for whatever you request, right? Whatever you request, that request has to serve via the presentation layer. You just requested facebook.com, then you requested for the images. So now image, the data is the reply packet has received to this user. That reply packet is in a form of jpg, which means image. Who are going to take the responsibility to present that? So that is going to take the responsibility of the presentation layer. See here, the presentation layer is going to take the responsibility. Whatever the request you have raised, right, that request will hit to the application layer, then the presentation layer will fall into the picture, and it is going to the represent. See here, the presentation layer, layer 6, is responsible for defining a standard format of the data, and it deals with the presentation. So it will deal with the presentation. You requested the jpg file, okay, jpg file to the Facebook server, right? Facebook server, he has sent some data to the application layer. Now the presentation layer will come. Oh, it is a jpg, which means image. So it is going to present you the image. If you send from audio mp4 or mp3 file requested for Facebook, Facebook will send that data, and again your presentation layer will come into the picture, and it is going to present in your screen. So that is what the presentation layer is responsible. Layer 6 is the responsible for presenting the data to user. The main functionalities on this layer is translate. It will translate, and it will encrypt and compress. Even we can compress the data, right? Ensure the data is in a usable format, which means you requested as a image, then this guy is going to send the jpg, which means this you can't directly open. Presentation layer has to take the action on this, and it has to present on your monitor. That's what the presentation layer will do. So few of the example here: ssl stand for secure socket layer, tlssl stand for secure socket layer, and tls tls stands for transport, l stands for layer, s stands for security. You need to remember the like examples, guys, okay? So if it is in jpg or gif means it's a graphic, which means image. If it is in ascii, which means text. Even we can encrypt and decrypt in this layer, presentation layer. So you just requested with the help of application layer, whatever the data will come to your machine, right, or the application layer, then the presentation layer will be responsible for your data to present you, and the session layer is responsible for, so from what time you have connected to the Facebook server and what time you have disconnected to the with the Facebook server is going to maintain by the session layer. And the transport layer, when you are initiating the traffic, right, when you are initiating the traffic, so it will add the services, which means the port number, whether you are going with the transport layer like the service TCP or UDP. Now we'll have a small diagram here. Router, switch. I'll just take one example. One user. Facebook server, YouTube, Gmail. You have the other servers which are connected to here, right? Over the internet. We have the multiple servers, multiple web servers in the here. See, guys, now physical layer means this is the cables. We are going to take the physical layer, and this is our layer 2. Router is layer 3, right? These are the hardware layer. Even this is layer 1. Cable means layer 1. We clear till layer 3. And layer 4 means what? Transport layer. Layer 4 will be, layer 4 is the transport, and the layer 5 is session, layer 6 presentation, layer 7 is application. Okay. Let me take the other pen. Okay. Now user is going to access this Facebook server, which means he'll initiate https colon / facebook.com. He'll try to initiate the request with the help of application layer. So here the application layer, right? Then that request will go to your switch, switch to router, router to that Facebook server. Then the Facebook will be login, right? Now in the second packet, you are going to request some data. Request in the sense you are going to request for images which you uploaded, right? Again you will get the reply. So now your sixth layer, presentation layer, will come into the picture, and it is going to the it is responsible, presentation layer is responsible to present the data in the user machine. Now whatever the sessions, what session layer will do, session layer will maintain the timings, that's it, will maintain the connection initiation and the connection termination timings. In the transport layer, so see here you are typing https, right? That https, so transport layer will take care about that. On which port? Transport layer we have a services, right? Services, we already studied that. Services, in services we have a like, service is going to identify with the port numbers, port numbers. So the port numbers, we have total port number 65535. So we studied that http service is going to use the port number 80, and the https is going to use the port number 443. So what port number here? The https, which means this router will decide, the transport layer will decide that it is a TCP service and using port number 443. This is what your OSI model, open system interconnection. That's it, nothing. Clear? Any doubts? If you have any doubts,
हाँ,
just let me
clear.
know. Okay, chalo. Right? We studied about everything, like about OSI layer, what is segmentation, sequence, how the sequence will happen, and everything. Right? Now I just need to show you something. Okay, this is a data flow. This is also important, how the data is going to be flow. Physical layer, which means cables, how the data is going to flow from the cable in a form of bits and bytes, which means zeros and ones, zeros and ones. That is why here bits, bytes, bits and bytes. Okay, bytes. Now that data is going to where? Going to switch. In switch, we will not say the packet. It will be a frame. Switch in the frame. Frame will receive to the switch. Okay. In data link layer, you will call as a frame. And once it go to the router, it will become the packet. See here. Okay, because it's a layer 3 device. Then in the transport layer, the segmentation will be happen, which means the breakage, if the packet is beyond 1500, which means beyond the MTU, maximum transmission unit, then the segmentation is going to be happen in the transport layer. And the session layer, the packet, the formation of the flow is as a data, and the presentation also is a data, and the application also data. We just need to remember here in these three layers, the hardware layers, right? Hardware layers. In the layer one, always its data will be in the form of bits and bytes, zeros and ones, bytes. And the data link layer, which means in the switch, the form is as a frame. And the network layer, layer 3 device, we will call as a packet. In the transport layer, segmentation will happen. The session layer, the shape of the data is pack data, data, data only. So this you need to remember. Now what we have, we don't have much anything. We have this slide. If you studied this slide, right, it would be easy to understand. Just let me go through this. So how we have a OSI layer, right? Open system interconnection, OSI layer. The same way we have the TCP IP layer, okay, a transmission control protocol, internet protocol. TCP stands for transmission control protocol, and IP stands for internet protocol. So in OSI model, we have 7 layers. This the about top three like below three layers are we are going to call as a hardware layers, and the above top layers we are going to call as a software layers or the user layers, right? And the same ways we have TCP IP model. In the TCP IP model we have four layers. One is, come here like this, application layer. This you can call as a host to host or the transport layer also, transport layer, and the internet layer, and the network layer. Clear? Network layer means it will fall like this. See here, TCP IP stands for the transmission control protocol. It is having the four layers: physical layer, network layer, physical layer, network layer, transport layer, and the application layer. So uh, these three, let me tell you one thing. These three become, these three layers till here, where till here, these three layers become the application layer. Okay, then there is a transport layer, two network layer, this, and this two layer become the physical layer. That's it. You can remember like this. Clear? So it is also used for the communication purpose. It was invented on 1970. Okay, both are the reference model. Both are the reference model. How the data has to be flow. We just had a reference model, right? When the user is initiated the traffic, that traffic will go to the layer 2 with the help of physical layer, which means cable. Then it will receive to the switch. This is our data link layer, layer 2. Then it will go to the router. This is our layer 3. And the remaining layer, transport layer, is there. Okay, that is the layer 4. And the layer 5, layer 6, layer 7 is as a software layer that you can't see the physically, but it will be work in the behind backend. So that is how the data like the reference model of the OSI model. The same ways we have a this layer, the TCP IP layer for the reference model. You just go through with this slide. If you have any other doubts, come to me. I'll be there here. I'll be here to resolve you guys. Now the summary. What we studied till now. At least you have to remember this summary. Okay, the summary of the OSI model. The summary of the OSI model. We have seven layers from start from the application layer to till like start from the physical layer to till application layer, right? What functionalities will happen in each layer? In physical layer, we have a transmission of data, right, in a form of bits with the help of cables. Clear? With the help of copper cable or the fiber cable. Now the second point, data link layer. Data link layer means what? The switch. In data link layer, we have two sub layers. One is MAC and LLC, media access control, addressing error detection and correction will happen. Where it will happen? It will happen in the switch. See here, we have a switch. Network layer. Network layer, what will happen? Which device we are going to use here? We are going to use the router, right? In router, we used to perform the routing. That is what here. In router, we have a logical address, which means IP addresses. This is what the functionality of the router. See here, we are going to use the router, and here we will have a IP address and the ping ICMP, Internet Control Message Protocol. ICMP stands for, guys, everything you need to like, you need to watch this video once again and need to remember and write down the points. This is important. I stands for internet, C stands for control, M stands for message, P stands for protocol. So your ping, right? Ping will work based on the ICMP. In ICMP, we have a ICMP request packet and ICMP reply packet. How it will work? ICMP request and ICMP reply. For example, this is my PC. Okay, I have a internet. There is a Google server in internet or the internet. Now I need to check the connectivity between from my PC to, okay, my PC, connectivity between my PC to the Google server. So what I'll do, right, I'll open here CMD command prompt and I'll check the command ping space 8.8.8.8. So what will happen? The ping will work based on ICMP protocol. In ICMP, again we have ICMP request and ICMP reply, right? So once you initiate this command from your command prompt, the request packet ICMP ICMP request packet will go to Google server. If it is alive, or if it is up, the response packet, which packet? ICMP reply or response packet will come. Then only you will get the TTL, time to leave. Okay, time to leave the value here. You will see the value TTL, or else request timeout. If it is alive, you will get the time to leave value, and the 5 packets you have sent and 5 packets you have received, 0% loss. If this server is not alive, then what you will get in the ICMP response? Okay, request timeout, TTL is 0. This is how. This is also important when we are start troubleshooting for the networks, right? Now where we clear about the network layer. In the transport layer, we will have a reliability, the functionalities. What functionalities we have in the transport layer? Reliable delivery of the data mechanism and the segmentation flow control. So the main example here is the TCP and UDP and the port numbers, right? Session layer, session management. So this is a things we can tell as an example. And the presentation, data translation, which means data translation, encryption and compression will happen here with the help of SSL, TLS, and image JPEG. Application layer is end user service and the application. Here we are going to use the example services are HTTP, DNS, SMTP, HTTP. Yes, this is what the summary of the OSI model, what we have spent our 1 hour of time. Now we need to understand this is very easily, because this is a practical example. Okay, when we are accessing a website, when you are accessing a website, this this is going to be happen on what layer, on which layer, what will happen. The layer 1, the frames are converted electrical or optical signal over the cable. It is going to send, means this is you as a user. Now you have an internet, there is some server over the internet, FP server. So if you are sending the data, it will go in the layer 1 with the help of physical layer. Your data is going over the cable. So there it is. Now layer 2, Ethernet frames. So in layer 1, the form of the data is in bytes. In layer 2, we will have a frames. In layer 3, we will have a packets. Then layer 4, we will have a segment. In layer 5, we will have a data, till layer 7, data, data, right? So here you will see the bytes in layer 1. In layer 2, Ethernet frames are created and transmitted within the local network, which means here we will have a switch. So till here to there, the data will go as a in a form of bytes, and once it reaches to switch, it will become a frame. Okay, then layer 3. In layer 3, okay, IP routes the packet across the network, which means here we have a router. It will go to router as a packet. Router will send that packet across the network at different networks. In layer 4, TCP segmentation. If the packet size is beyond 1500 MTU, maximum transmission unit, that packet is going to happen. That packet will perform, the router will perform the segmentation and that ensure that it reach the destination. Router will do the routing part and it will send to the destination site. Then in the layer 5, right, a session is established between your device and the server, which means from this user machine to this server, the session will be established. That session layer will come into the picture. Now in the layer 7, the request may be encrypted using a TLS, which means when the data is traveling over the internet, see, till here your office, right? You can do any kind of data, you can encrypt the data, even you can, if you will not encrypt also, there is no much issue. But if the data is going here over the internet to this particular server, the data has to be but definitely encrypted, because there your security will come. So we are using TLS, transport layer security, which means SSL, You will see in industry like this SSL-TLS, secure socket layer over transport layer security. We are going to use some kind of encryption mechanism. This is what the encryption. We are going to use the encryption mechanism and we are encrypting the data and sending to this particular destination server. Then this is what the browser in the layer 7, your browser or application send the HTTP or HTTPS request. So from here you will send the request. This is what the practical scenario. You just need to go through once or twice, then it will be understand. And why the OSI model is very important in the IT networking means it will provide the standardization, right? See here, standardization provides a universal language for describing networking functionalities and troubleshooting. It will useful in the troubleshooting also. The troubleshooting helps isolate the damages, diagnose network issues, identifying the layer, which layer is affected, and assist designing and design, assist in designing and understanding complex network architecture. So complex network architecture you can consider like this. See, if you have this kind of architecture, what you will do, right? If you have this, so you can easily understand that this is our LAN. This part is whole part is our LAN. If you don't know the OSI model, how you will identify that this is the LAN network? And you can consider this also the LAN network, no, right? So this is a WAN network because whenever the outside network it is a WAN network, you can easily consider this is a LAN network. LAN network cable, the layer one. When if this port goes like faulty or this cable is faulty, it will, even the OSI model is responsible. It will help when you are start troubleshooting also. So you can ask them, hey, there is a layer one issue. Layer one issue means what? The cable issue. If the switch is having any issue, right, it is a layer 2 issue means the switch issue. Layer 3 issue means IP routing, any routing related issues. And if this application will respond only on port number 443, if our user is requesting youtube.com on port number 80, that request will not work and you will get the logs in the router. Not only in router, you will get the logs in the firewall that the server is not responding. Then when you check the logs, right, you will see here the service, the port number is not matched because the destination server is will work based on the port number 443. Then you can mention that, hey, it is a layer 4 issue. Layer 4 issue means, so this is how you can what isolate the issue. But you can able to ping from here, from this machine to youtube server. You can able to ping from youtube server, from youtube server to this sorry, from this LAN machine to youtube server, but you are not able to access on port 443, port 80 https because this service is using 443 and you are trying to access with the help of port number 80. So you can consider that, you can say that, hey, firewall team, so that the destination server is working on port 443, so we need to allow the port 443. So that's how we can tackle the issues. We can resolve the issues. Okay, we can isolate the issues exactly. So OSI model is very important. So if we, before winding up the session, we just have a glimpse of OSI model. In OSI model we have a 7 layers, right? Starting from layer 1 physical, then data link, then the layer 3 is the network layer, layer 4 is at the transport layer, layer 5 session layer, layer 6 presentation layer, and layer 7 is application layer, right? Each layer is having their own functionalities in the OSI model to send data in the data transmission. Okay, different layer will take care of different functionalities. How we have the OSI model, the same wise we have a TCP IP model as well. In OSI model we have a 7 layers. In OSI model, sorry, in TCP IP, transmission control protocol, internet protocol model, we have a 4 layers, right? So about 3 layers here, we have about 3 layers, right? Application and the presentation and the session layer is will become a application layer here. Here the fourth layer, transport layer, will become the transport layer here. Then here network layer will become the network layer here, same we can use. And here the application layer is there in the layer 1 here also. Sorry, the physical layer, guys. Physical layer is here also, physical layer. So in TCP IP model we have 4 layers. right? Application layer, transport layer, network layer, and physical layer. In OSI model, we have a 7 layers. This is what about the OSI model, open system interconnection, which was invented by ISO in the year of 1984. Clear? So thanks for joining Network Ninja. Let me stop the recording. Okay. Thanks for joining Network Ninja. So just go through the video and like